Okay, so we're going to look at how we calculate binary, but for us to understand that, we're going to start looking at decimal. So decimal is the numbering that we use in maths. So when you're doing any number work in maths, you're using the decimal numbering system. And this can also be referred to as base 10, as there are 10 possible different numbers that you can use. And you can see on the screen 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 are all the possible numbers that we have within decimal. So even when we start to get past the number 9, so when we get to 10, 10 is obviously just made up of a 1 and a 0. So again, just reusing of these numbers. So if we said, for example, in this table, the number 3 is just 3 lots of 1. When we say 23, 2 lots of 10, 3 lots of 1. When we say 123, we're saying 1 lot of 100, 2 lots of 10s, 3 lots of 1s. And you know that this goes 1, 10, 100, 1,000, 10,000, and so forth. And that's how we use our numbers. Now, in maths, you'll notice within our decimal numbering system, this increases by a multiple of 10 each time. So 1 times 10 is 10, 10 times 10 is 100, 100 times 10 is 1,000, and so forth. And you may never have noticed this before, but it's kind of that idea of that hundreds, tens, and units that you'd have maybe been taught at primary school. And our numbers are all made up of these sort of simple calculations. So when we look at this, if we're saying the number 3, just under the 1 column, is 3 lots of 1. When we're saying 23, we're saying 2 lots of 10 plus 3 lots of 1 make up 23. And if we would say the same for 123, we'd say 1 lot of 100, 2 lots of 10, 3 lots of 1. And this is something that we've probably grown up and are very, very familiar with. We can apply that same idea to binary. And the way that we do it is this. So binary is base 2. So instead of having 10 possible numbers, we only have 2 possible numbers. And this is because computers work using electricity, and they can either be on or off. So we think of a 0 being off or no, or a 1 being on or as a yes. And this becomes important as we move to the next part. Now, remembering that in our decimal numbering system, we go up in multiples of 10 each time because we've got 10 possible numbers. In our binary numbering system, we go up in multiples of 2 each time because we only have 2 possible numbers. So instead of going 1, 10, 100, we go 1, 2, 4, 8, 16, 32, 64, and 1 to 8. And that's as high as we're going to go. Now, when we want to create our numbers, we use our combinations of zeros and ones in order to tell us whether or not we're using that number. So in this first row here, we've got a 1 underneath the 1. That means the number is 1. In this second row, we've got 1, 0. So we're saying we want 1 lot of 2, 0 lots of 1s. So we're saying 2 overall. Underneath that, we've got 1 lot of 2s, 1 lot of 1. So 2 plus 1 is 3. Underneath here, on this one, get a little bit more complex now. What we're saying, and I've shown this down in this sum down the bottom here, 1 lot of 8 plus 1 lot of 2 equals 10. So 1 plus 2 equals 10. And that's all binary is. Binary is just using different numbers across the top. So just looking at this big number at the bottom. So we've got 1 lot of 128, 1 lot of 32. Those two added together equal 160, 1 lot of 4, and 1 lot of 1. So we're saying 160 plus 5, so 165.